Today we will discuss about counters. So counters is one of the most useful circuits in digital system, and the purpose of a counter is to measure the number of clock pulses uh, given to the counter, and basically we are counting these um, clock pulses and converting it into decimal equivalent numbers. There are two different kinds of counters, different types of counters, that is synchronous and asynchronous counter. In the case of an asynchronous counter, the output of the first flip flop is given as the clock to the second flip flop, and similarly the output of the second flip flop is given as the clock to the third flip flop, and so on. That is why it is called an asynchronous flip flop, because there is a delay in triggering the next flip flop, because once the first flip flop set, then only the second flip flop uh, can active or not active. Okay, so that means there is a speed limitation. And in the case of a synchronous counter, we are giving same pulse to all the flip flops. In this case, we are discussing only about the asynchronous counter. So asynchronous counters are also called ripple counter. Why it is called ripple counter? Because this counting process is like a uh, ripples in the water, that we will discuss now. So the circuit diagram is shown. A 3-bit binary triple counter is shown. Here we are using JK flip-flop to make asynchronous counters. Both J and K inputs are tied together and connected to a plus VCC. So that means J is equal to 1, 1, K is equal to 1 always. Okay, so and a clock pulse is given to the first flip flop. That is a negative edge triggered clock pulse. That notch at the center indicates a negative edge triggered clock. Then output of the first flip flop, that is A, is given as the clock to the B, clock to the second flip flop, and output of the second, that is B, is given as a clock to the third flip flop. Okay, so since both J and K are always at 1, depending upon the clock, whenever there is negative edge of the clock comes, the output changes. So first flip flop is changing its state when the clock pulse changes its state from high to low. And second flip flop changes state only when the A output changes from state high to low. And similarly, third flip flop will change state only when B changes its state from high to low. So mm, you can explain it by using a timing diagram. Here you can see the timing diagram is shown a clock pulse, then ABC outputs are given. So initially we are resetting the circuit with 000. Now the first clock arrives, and when the clock goes from high to low, A will be changing. Okay, because it is negative edge triggered. So the A was initially at 0. So since both J and K are at 1, it will toggle whenever there is negative clock pulse comes. So at the point A will trigger from 0 to 1. At point B, again it is going down from high to low. Again A will be changing. It was at 1, that will go to 0. At C it will go to 1 again. At D again it goes to 0, and keep on doing like that. And the second case, B, we know that B is triggered by the A output. So that means since it's negative, it's triggered whenever BA goes to low, B will be changing. So at the point B, A is going from high to low. Correspondingly, B will be shifting from 0 to 1. And similarly at D, again A is going down, so B will be changing its state. And at F it is changing, and again at H B will be changing. So whenever A goes from high to low, B will be changing its state. Similarly, C will be changing state only when B changes its state from high to low. So at point D and H, B is changing from high to low. Correspondingly, C will be changing its state. Now, if you measure the output, C will consider C as the most significant bit, and A is the least significant bit. So at point A, if you measure you can see that at point a value is 1, here a value is 1, b value is 0, and c value is 0. So this corresponds to 0, 0, 1. At point b, again you can see that the value of z is 0, b is 1, and a is 0. So this corresponds to 0, 1, 0, and that is equal to the count 2. And similarly at point c, you can see it is 1, 1, and so on. So finally at the point G it will be 7, 7, seventh count, and at H again you can see it is 0, 0, 0. So it is starting again. So so by using three flip flops you can count up to eight. You can count from 0 to 7. That is 8 counts is possible by using this type of uh, ripple counter. Okay. So this whole things are explained here. You just go through this.